Hello, everyone. Can you hear me?
Yes.
Yes.
Okay, great. Okay, fantastic. So let's wait for probably 1 or 2 minutes before we get started. Okay. And this is a truly exciting time. Some of you might have heard recently, just a few days ago, a few important AI inventions have been announced. First is the OpenAI released the so-called, I think it's called personal or individual GPT, allowing us to design our own version of ChatGPT. I haven't really played much with it, but it seems to be the interface is very intuitive. You can use natural language to dictate how ChatGPT are going to perform. You can put your personal information and allow GPT to do some specific tasks. And there are several dozens of personalized GPT already there. I think they were all created by OpenAI as examples, but we have access to those functions, and we can create our own versions of ChatGPT. That seems very interesting. I don't know how flexible we are though, but it seems to be intuitive. And the next big thing is the AI pen. I'll post it here in case you haven't heard about it. So the AI pen was a new product that is going to be on the market very soon, probably by mid-November. And the company that produces the AI pen is called Human. The CEOs are a couple that who previously worked in Apple for years, and several years ago they decided to quit Apple and have their own startup. And many know this giant high-tech companies such as Google, OpenAI, Microsoft invested in this startup, and in 5 years they built this AI pen, which is literally a very small device that you can put on your coat, your shirt, that is connected to OpenAI ChatGPT models that can speak with you, translate language in real time, and also has a screen that can project to your hand. You can use hand gestures to dictate the function of the pen, and it also connect to the cell phone signal, so that you can use it as a phone. And the concept of the AI pen is to replace Apple's the iPhone, because the CEOs of Human claim that it was guilty for them to produce this iPhone, and now it's the time to change. So instead of addicting to the screens, they argue a more intuitive way to interact with AI is through gestures and natural language. So but it's not cheap, right? The online price is $6.99 plus a $24 monthly pay for the cell phone signal use. Okay. So feel free to check it out. If you really want to be on top of the AI wave, I guess AI pen could be some devices you want to have. But personally, I'm going to wait for a while. I'm going to see how it is received by the society. because many devices have failed miserably, such as Google Glasses, and recently the Meta smart glasses. Okay, so neither of them actually were well received by the society. So there already are various issues associated with battery, the segmented functionality, etc. Okay. So that's really exciting. I would say, in this AI field, taking the right and see many technologies being developed almost on a daily basis. Okay. So that's now I think it's the time for us to move on to the talk. And today, I'm really happy that she take the lead in developing this talk around the SAM's model. And SAM model is the largest image segmentation model that I've ever known of, and it was trained on huge amount of image data. And it produces state-of-the-art results. Really, as the name suggests, it can segment any images, literally. So I asked she to do some homework, analyzing the SAM's model to see the usefulness, and also in connection with the object detection model, such as YOLO, to see how we could leverage the power of both models to annotate our data automatically. So without further ado, the floor is all yours.
Thank you, Professor, for your introducing. So I'm gonna sharing my screen. Can you see it? Okay.
Yes.
Okay. So for today, I am going to introducing you like computer annotation a vision model called segment anything model. And the outline for today is totally 5 parts. First of all, I want to introduce you the basic of the SAM model, and then I want to introduce you the combined use of SAM with the RobotFlow platform, and its combination from the YOLO model to do the auto annotation. And then I would like to introduce you a fine-tuning of SAM on the medical image. And then we will talk about the future trends and more applications of it. So what is a segment anything model? We need to know first is the segment anything project. The segment anything is a new project by Meta to build 2 important components. The first is to build a large data set for image segmentation, and then is to train a segment anything model on those data sets. So the segment anything model is trained on a very large database. And you can refer to the segment anything paper by adding this citation. And what is the segment anything model? So as you can see on the picture is that when you put different kinds of images to the SAM, it will generate you the segmentation of the whole image. And within the image, it generates very specific regions professionally. And this is very fascinating. So there are 2 main characteristics of the model. First is it simplifies the segmentation process, because as you see, it can segment everything within an image automatically. And then another fascinating characteristics is that it can be prompt with various inputs, including clicks, boxes, or text. It means that if I just simply click on the item I'm interested in, then it can segment it directly, only segment this objection. So let me introduce you how to do it. So when you on the segment anything on com website, it introduces you the basic using of it. You can go to the demo and choose any picture you want. Let's say this dog. And then you can directly click on the dog, and the dog can be directly be a segment. And you can cut out it. Cutout objects, yeah. And it will show the cutouts of this specific objects. And you can also like do other prompts, like you can using a box boundary to tell the SAM how to focus on the objects you want. And we will introduce you later on the Robo platform.
So see, just one comment for those of you who are not familiar with segmentation. So segmentation means that we have to do a pixel level prediction. So think about images consist of pixels, right? It could be a height of say 200 pixels and a width of 400 pixels, right? And on each of those pixels, the model do a prediction on which object this pixel represent, right? It is a cup, it is a knife, it is part of a table. So the segmentation model try to make prediction at the pixel level. So each pixel belongs to one of the clusters, and each cluster represent a object. So consider this, the segmentation models are very complex, right? Because we are not really predicting a single label on an image, we are predicting every single pixel in that image. It is computationally heavy and very difficult to do. Okay, so that's just a brief intro to some of you who are not familiar with image segmentation.
Yeah, thank you. Yeah, thank you, Professor. Professor just introduced how this model being how this model being created, and then we will talk about how to use it on the different platform and combine it with different models. Before that, I want to introduce you the workflow of the SAM model. So how does the SAM work? There are three important concepts of it. It is the image encoder, the prompt encoder, as well as the mask encoder. So in SAM too, there are three important components of the modes. So it is the three. It is the two encoder and the one mask decoder. So so first, when you put an image in the model, it will be processed to the image encoder, and then it will generate a list of the data in the model. And then, as you see the prompt encoder, you will give the model a prompt, like a box or a click or some text information to it. And then both of the two information put in the model can help you generate the realistic, the final masks or the final segmentations. And how does this work? We can use it on image annotation platform called RobotFlow. RobotFlow is a computer vision platform designed for users to create datasets, train models, and deploy to productions. When we go to the RobotFlow, as you see, it can help you to annotate images. So let me introduce you an example. First of all, I want to let you know that the universe is a very useful function on this platform because many users sharing their pictures annotated or unannotated on this platform. You can directly choose them to your own projects and train your own model, do your own annotation. As here, I am annotating knots, different kinds of knots. And right now I have already finished the annotating. Okay. As you can see, I opened this platform to do the annotation. So how does it work? First of all, as you can see, the traditional way to annotate an image is to using a boxing to mark the boundary of this specific object we interested in. And then we can add different labels like macadamia. This is this knot's names, and click on save. This information would be saved for this specific objections. But now on the RobotFlow platform, it already combined with the SAM model, so we can directly use the smart polygon function. As you can see here, it is being powered by the segment anything model. So if we use this and we directly click on it, it immediately be segment, and you can easily just click on finish, and this very specific professional plot has the region plot has been generated. Okay, so this is a way, like as you can see, you just click on this objects, and the SAM can directly signify what the shape of this knots and give you the relative segmentation to it. So it is very useful in the annotation process. Facilitate us to do the different kinds of annotation tasks.
Yeah, and one thing to add here is the SAM's model do segmentation, but doesn't do the labeling. So SAM model doesn't know actually what object it is because it's not trained on the ground truth labels. It is great at segmenting almost everything, but then no, you have to annotate, or you can use other models as you're going to show you to label and annotate the object names because SAM model doesn't provide those names.
Yes, thank you, Professor. And so Professor just mentioned an important thing is that SAM can only do the segmentation tasks. So it needs many prompts for him to segment specific objects, as well as to use other model to do the labeling tasks. So right now I am going to introduce you the SAM with the YOLO model, which is a great object detection as well as labeling tasks model. So YOLO is called You Only Look Once model. It is a state-of-the-art real-time object detection system. So we can take a look of it. So right now, YOLO already iterated for many times, and the latest version is YOLO 8M. As you can see, there are many different YOLO 8 model, and the different model is used for different tasks. For YOLO V8, it is used for detection. For YOLO CLS, it is for classification. And we will use this tool to do more introducing example in later. And how to use YOLO with SAM? First, very simple is that YOLO detect the objects and add the labels. So as you can see here, we can see two different box boundary here. So YOLO's task is to identify different objects. So after we apply the YOLO model, we can object the two objects in this image. And then we send the results of the box. As you can see, it is a brain boxing boundary. We send the information of this boundary to the SAM model. And the SAM model can use this information as a boundary for him to generate a segment, relative segment within this boundary. This is because, as you can see in the former pictures, the SAM cannot like identify specific objects you interest. If you are just interested in this orange, SAM cannot directly segment the orange. It will segment everything on the image. So if you only want to identify orange in the image, you have to tell SAM, I want you to segment this area only, specifically. So that's why we use YOLO to do the box boundary task. Okay, so here I will show you an example. Okay, so first of all, we download the models we need, and we also import the SAM weights, which is the SAM model, and then we input an image. This image, as you can see, we have like 1, 2, 3 dogs and 2 cats, and we want them to segment each of them. Okay, so when you when we also define a YOLO 8 detection model, this model is this one just introduced. It is good at detection, and in the first step, I only use this YOLO 8 model to do the both detection and the label task. So I import the image and use the YOLO detection to do the label and object detection tasks. And it generates this result. The YOLO identified 2 cats, 4 dogs. As you can see, actually, we only have totally 5 animals. Why it generates 6? But we can talk about it later. And then I also printed all the label because YOLO works. How YOLO to do the labeling is because it already has a data set of the label. So in this YOLO 8 model, we totally has like 79 labels. So it can only identify the 79 different labels it already been trained. If you give them other things do not include it in the label, it may not recognize it it cannot perform very good in the labeling task. So the YOLO model here identified the dog, 3 dog, 2 cat, and 4 dog and 2 cat. And here I presented the corresponding box boundary of each image, of each object. And as you can see here, we can see the result. So the YOLO creates the box boundary for each animal, and it also adds the labels to each animal. But the YOLO also like created 2 boundaries box for this animal. And it seems has a different name labeling on it, which means that YOLO cannot identify this animal is a dog or a cat. So it has two results from this image. And then I combined the YOLO classification model with the YOLO 8 model to do different tasks. I only want to use the model, the YOLO 8 model to do the boxing boundary task. And I want to use the model YOLO classification model to do the labeling, because the YOLO classification model has like hundreds of labels, which is more than the detection model to do the separate tasks. And then after running this code, I got this result. But even though I use the classification model, it still has two kinds labeling for this animal. Okay, so now we can using SAM to do the segmentation within each boxing bounding. You may think the results of the segmentation is look like this. You may think, well, if I send this picture to the SAM, it also can generate all the segmentation as this one. But the working mechanism is different, because actually in here, I tell SAM to do the segmentation within this boxing and within this boxing. So SAM actually has done 6 tasks. It not generate this image just in one process. Okay, so how to using SAM to do the segmentation within each boundary? Yeah, we set the SAM model and sent the boundary information to it, and then we generate the relative masks from the boundary. This is the basic idea of how this syntax works. Okay, you can refer to the details later to have your own idea.
So could you go back a little bit? Just show us the how you connect the SAM model with the YOLO model.
Oh, okay.
Probably this part. Okay, so you call this model using SAM model registry. You provide the model and checkpoint. So basically, the checkpoint would be the model weights, and then you send that to GPU. After that, you call the SAM predictor. So you get the SAM predictor. So this function is provided by the SAM model, right? Basically just use the model for prediction. And then okay, you set the image to probably SAM format, and then convert that to tensor, right? The input boxes to tensor. Because so here basically you converted the YOLO bounding boxes to PyTorch tensor, right? So that's called input boxes. And then you call the predictor, you transform the boxes here. So that's probably transformed to a format that is acceptable to SAM model. And then you so here you create the masks, right? So likely the predictor, besides creating masks, also producing something else, but you only need the masks. And then you iterate the masks, because you have six objects for segmentation. So there should be 6 masks. You just iterate each of them. and then you find the contour of the mask and get the bounding boxes, and then get a segmentation mask for each object. Okay, so that's interesting. You get those code from the YOLO model. The YOLO model is the on their website. Is that right?
I get it from a blogger.
Oh,
So
okay.
part of it's his code. I will share it in the reference.
Yeah, that's very interesting. I haven't seen this being done. Yeah, what I saw is just the YOLO website. They provide some explanation, but I don't think they provide the way that we can do it.
Oh,
Yeah, so this is going to be very helpful. Yeah, so if you
yeah.
could later on maybe add the web page to the blogger, and then yeah, we can take a further look if we have further questions. But this is
Yes.
fantastic.
Yes. Yeah, thank you, Professor. Okay. So here is the conclusion after we done this after we run this code. I think basing on my own knowledge, I think the YOLO mark the region and the corresponding label, and the SAM do the segmentation within the YOLO's working results. And we input an image in this process, and it will generate the segmentation annotation as well as the corresponding segmentation image results from it. Okay, then I want to introduce you the simple fine-tuning of SAM. So although SAM has a powerful zero-shot generation capabilities, its direct recognition performance is in highly specialized domains is not very good. So you have to adjust it to your specific tasks. And a simple fine-tuning is enough for it to do very professional jobs, especially like in the medical area. And here, I'll show you a code. Okay. So as we all know that what is fine-tuning mean is that we can in our deep learning models, we have many different layers. And in the last several layers, it is more specific to the to the objects we interested in. So if we want to fine-tune a model for our specific tasks, we need to find only training the last layers. So here, in this example, it shows you that how to fine-tune the SAM model. We create the SAM model here to the medical image by just using one epoch. It can show a good performance on prediction. I think the training process is very familiar for you already. So I just want to show the most important code here. Oh, it's the output. I'm sorry, this seems not my. Anyway.
Yeah, actually we can read from there. Yeah. So okay. So what you got is you have this. No, for those of you first who are not familiar with fine tuning. So here is a brief intro. So think about SAM model, and many large models have been trained on millions of images. As actually for SAM model, it has been trained on 14 million images and more than a billion annotations. Right? So it's huge. And then the model has been open sourced and everyone can use, right? So what she does here is she downloaded the entire model, including both architecture as well as associated weights. There are millions of weights possibly in this model, right? Each weight is a floating number that has been optimized. And then the term fine-tuning means that now you have some new data, right? And you want the model to learn from the new data, but you don't want to train the model from scratch. In this case, you can borrow the existing model weights as a starting point, as the initial parameters that you can further optimize when you train the model on some new data. So that is called fine-tuning. So fine-tuning is very economical compared to training model from scratch, because otherwise, you have to have your million images. That is not possible, nor people like us have the power to train those models, because usually the models occupy hundreds, if not thousands of GPUs and compute for months, right? So the expenditure is a few $1 million to $1 billion, right? So usually for researchers, we don't train our model nowadays. We use some model if there's a need. For example, here, in terms of medical images, because the model doesn't do a good job, because the model doesn't probably train using medical images. So in this case, we can fine-tune the model with, say, a few hundred to a few thousand images like this. But to train this model, you need two parts. You need the original image, shown here on your left-hand side, but also you need to have the masks associated with the image. Okay, so and the mask serve as the ground truth. And what the model does is try to learn the association between the original image and your ground truth, which have already been predicted at the pixel level.
Yeah.
Okay. Yeah.
Yeah. Thank you, Professor. So like fine-tuning. Professor introduced the fine-tuning very like clearly, and I also want to give you an example of the fine-tuning. Like you can imagine the ChatGPT, which is a natural language like very basic model, and you can ask him anything and it will generate something he already knew and performed very well. But if you ask them something very specifically, professionally, it may not give you very good results. So you have to tell him very specific articles you interested in first, and then you ask the relative questions. So here, SAM is the same thing, similar to like ChatGPT. So you need to like fine-tuning the SAM, and then it can do a prediction better. And so here is the code to fine-tuning the SAM model, which is to like to frozen the last several layers, and then use your specific medical image to train it.
So if you go back, so I want to briefly explain this because people may not get this idea.
Yes.
Yeah. So here, so basically, remember that when she introduced the SAM model has 3 encoders, right? It has the mask encoder, and also the prompt encoder and the vision encoder, right? So here, what she mean by simple fine-tuning means that we don't retrain or we don't really update the parameters in the prompt encoder and the vision encoder. So therefore, here she set them to requires gradient to be false, meaning that no, please do not update those gradients. Please do not update the parameters, so that basically the parameters in division and the prompt encoders are frozen. Frozen means don't change them, right? Keep them as they are. And so in this case, when we do the fine tuning, the model will only update the parameters in the mask decoder. Okay, so that is the why this code is important.
Yes. Thank you, Professor, for your illustration. And as we can see, we run this training process for 100 times. But actually, I have run it before our presentation for only run it for one time, and the prediction result is still very good. So here the result, it will show you the ground truth mask, and then is the trained prediction masks. And let's see the results. As you can see, the results is pretty good. It's almost like the same as the grounding truth. This is the prediction one, and this is the grounding truth. So it works very well. And because it only it's only a fine tuning, so it's very time saving for those experts to train their own specific medical model.
Do you know how much data do you have in terms of number of observations in your training set?
I remember it's like 600.
Okay, so it's a fairly small, small sample. But on the other hand, think about the annotation is at a pixel level, right? So it is labor intensive.
Yeah. Thank you, Professor. So this is a very good tools for us to leveraging SAM model to do our own professional job. And now I want to introduce you some interesting applications of the SAM. So for the public health area, we need to know specific population densities in area to define the allocation of specific public health resources. As we take the COVID-19 vaccination as an example, the Facebook has built a model to predict one area's population density, and then to distribute the related COVID-19 vaccination based on those model prediction results. And this example describes this method for predicting the population by identify buildings. So how you identify buildings, you need to use many methods, and you need to combine different technologies. So within this technology, it contains the SAM model to identify the different kind of buildings on a picture, on a photo taken from a very far away space. And so it can after recognizing a building, then you can inference this area's population densities. So it is very useful technology. And as you can see here, is a map of Pakistan. The false positive from the original model is blue. So when you see the blue, there is a lot of false positive results. But after using the new model, we can only see this lesser green spot, which is also the false positive from the new model. So it performs better to do the prediction in the population density. So by simplifying this signification process and reducing the need for task specific models, the SAM empowers users across diverse industries to tackle image segmentation challenges with unprecedented ease. By simplifying the segmentation process and reducing the need for task, SAM empowers users across diverse industries to tackle their own professional tasks. And this also offers us many opportunities, probabilities to flexibly using it to do more future jobs. And here is the reference, and I also will send you the link of my other code reference. Thank you very much.
This is fantastic. So I personally learned a lot from this presentation. So thank you, Xi, for taking the time to do such a thorough job. So I know about three weeks ago when I told you, no, it is a great undertaking, and because the model is so new, both the YOLO model and SAM model are very new, and I personally don't know a lot about them. So I used the YOLO model to some extent for classification, but I've never used the SAM model. So when I ask you to do this, no, I send you some references, but it seems like you explored a lot more than the references. So this is truly informative.
Thank you for
yeah, thank you for the effort. Any questions from the audience? Anything that you probably don't get the idea, you need further clarification from Xi or from myself, or any inspirations that you probably are likely doing later on for your own projects using SAM's model or YOLO models?
Professor, I had a question about the image annotation. In one of the images with the train, there was also measurement mentioned with the figure, like with the segmentation. So what does that figure indicate? Is that pixel, or is that like any other kind of measurement with that segment of the object?
Right. So and Xi, probably you can answer that question.
I'm sorry, Sabi. Can you like
Okay, sure. I think like and can you go back to your slides, like where you have mentioned about there is a image of the train and there is also a person image and it's segmented. Yeah, this
here?
one, like just after this slide, yeah.
This?
Yeah, exactly. So with this segmentation, you can see like with the train, it's written 0.93, and with the person, it's written 0.70. So I'm not able to understand what does this number indicate with those segmentation.
Oh, well, I think it is kind of like when you do the labeling, you are using the YOLO model, right? So when you run the YOLO model, when the YOLO model do the prediction, it have to it is still before the labeling be labeled. It is the results of the prediction is a number, as a specific number. So if the number is 0.93, it is more likely to be a train. If it's the number is, if the final score is the 0.7, it more be probably is the person. So I guess this is the labeling corresponding the calculating prediction scores from the YOLO model. And the YOLO model transfer the number to specific label, which already been put in the YOLO model labeling systems before, and it just directly translates this score to train to do the labeling. Does that make sense? But I'm not quite sure.
So yeah, no, that's almost correct. So a few things here. So basically, this is think about you have your YOLO model trained, right? And then you going to use the YOLO model to make some prediction, right? So the prediction is raw, we call it raw logits. And then we used Shanbabi, probably you remember that we have a prediction head, right? And the head is going to transfer that raw logit into a probability, right? So here basically 0.93 means the model is 90% sure that it is a twin, right? And 70% sure this is a person, right? And then what she does is she used the output of the YOLO model prediction as the input for the SAMS model. So SAM model know where to start with, know what object SAM model should pay attention to and segment, and beyond the bounding boxes, SAM model does not pay attention, does not need to pay attention to. So this actually is a way to tell SAM model what to segment and what not to segment, because we are only interested in the twin and the person. The other object, for example, the railway, the building, the light pole, that we don't care them. So we don't ask SAM model to pay attention to that and segment that from the other objects.
Okay. Yeah. Thank you so much,
Great.
Professor.
Sure, great question. Any other questions and comments? No, I would say I would be surprised if you if you are not inspired, because there are tons of questions that we can answer using this type of model, right? So SAM model is huge. It can only do annotation, but don't really recognize the label, whereas the YOLO model is much lighter in weight, and it is great in real-time recognition, object detection, and labeling, but can't really segment the object as well as the SAMS model does. So a true combination, a powerful combination, would link those two models together. In this way or that way. So basically, she shows one way, that is you use the YOLO model first, right, to identify objects, and then use SAM model to segment it. And you can do the other way around, actually. In the YOLO model website, you will see that actually there are some tutorials about, well, first you use the SAM model to segment everything, and then you just use YOLO model to identify some of the objects. Okay? So that would be another way to identify objects. And both you can find some tutorials there. As a data scientist, we are learning new things all the time. As she demonstrated here, for a lot of time we just don't know, right? We just Google, or if we don't want the name Google, we Bing, right? Or we open AI, we chat GPT things, right? We basically figure out things on the fly. No one really know how to do all of them, right? It's just not possible. The emphasis is that not you remember anything. You don't really need to remember anything, but you know where to find things when you need them, right? So that is very different than the sci-fi movies that you watch, that those super intelligent hacker, they just keep typing, right, in a terminal, on the fly and without even looking at anything, right? But that is not possible. Okay, so in reality, data scientists are Googling or chat GPTing all the time. Okay, because we know how things work. If we want to combine things, we just try to find something on the internet. And now we have the fantastic large language model. Although, well, usually the model give you some code that may not run the first time, but they are good starting points. Right? So you don't need to reinvent the wheel. If someone manually have done this before and posted on the web, what is the point for you to do that all over again, right? So I would say that is probably the way that we learn data science. It is not really to memorize code, and we need to adapt to a new way of adapting ourselves to various environments, various new inventions. Okay. Okay, so any other comments, questions, no clarifications? Okay, so that will be a short meeting, but very informative. Really, we can't really judge the quality of the talk by length, right? What is important is we learn a lot, right? In as short time period as we could, because we are all busy. And just to remind you that we will not meet in 2 weeks because, well, no, we are going to celebrate the Thanksgiving, right? No, at least in the United States, right? We celebrate Thanksgiving. We will have some friends coming by, and I'll have an international trip lined up. So we are probably going to see each other in 3 weeks, though. No, maybe 1 week after Thanksgiving. And we will send reminders at least one week in advance, so you know when we are meeting. But surely we are going to meet, and we have a lot of interesting topics to discuss. So in the next meeting, we'll welcome Charles back on stage to talk about some specific prompt engineering and fine-tuning techniques that I personally don't know much, right? I want to learn myself. I know I'm selfish, but well, no, we all learn, right, from each other. So yeah, and thanks for Peiqi and your great message. Again, we thank you, Xi, for your fantastic presentation. That really educate us on how to use SAM model plus YOLO model. Okay. Thank you so much, everyone. And we wish you, a great holiday, Thanksgiving break, and have some time to relax. We'll see each other in about 3 weeks. Stay tuned. Bye, everyone.
Bye, Professor.